The single most valuable 15 minutes you can spend in a commercial building is fixing the HVAC schedule. Not replacing equipment, not retrofitting anything, just correcting when the HVAC system actually runs. The Department of Energy estimates that improperly configured building management systems account for up to 20% of commercial building energy use. Much of that, in practice, is schedule drift. This video is on how to find it, how to fix it, and how to know the fix is actually working. I'm Nicholas Napp. Schedule correction is the first fix data almost always finds in a small commercial building, and it's the one that pays back fastest. Let's dig in. HVAC runs between 40 and 60% of total energy use in a typical small commercial building. According to EIA's Commercial Buildings Energy Consumption Survey, or CBECS, HVAC is the largest single end use by a huge margin. Everything else, lighting, plug loads, hot water, is a smaller share. Which means the single biggest lever you have on energy use in a small building is how many hours the HVAC system runs for. Not how efficient the chiller is, not how well the envelope is insulated. Those do matter. But the first order variable is runtime. If your HVAC runs for 4 hours longer every day than it needs to, that's roughly a 20% energy penalty on the largest line item in your utility bill, multiplied across 365 days every single year. Schedules go wrong in 4 predictable ways. Number 1, wrong occupancy hours. The schedule was correct when it was set, maybe, usually at commissioning or at the last tenant turnover. The building then changed. Tenants came and went, hours shifted, a space got repurposed, but the schedule never was updated. Maybe one office added Saturday afternoon hours, but HVAC's still on a Monday to Friday because nobody touched the controller. A second one is missing holidays. A commercial HVAC system will happily condition an empty building over Thanksgiving, on Christmas, 4th of July, and during the entire winter break at school because the holiday schedule was never filled in or has been wrong for years. For a school, this alone can be 10 to 12 weeks a year of fully scheduled HVAC with no occupants. Number 3 is nighttime setback failures. A setback is supposed to drop the target temperature during unoccupied hours so the system does less work. The setback's programmed, but the system isn't actually hitting the target. Common reasons are a zone override that was maybe set for a late event and never cleared, or a sensor placed in a drafty hallway that fools the controller, or a software bug that never got a ticket. Number 4 is a pre-start overshoot. The system is programmed to reach comfortable temperatures by 9 a.m., so the controller starts cooling maybe at 6 a.m. to give itself margin. In many buildings, that pre-start might only need to be 45 minutes, not 3 hours. Those 2 extra hours are pure waste. All 4 of these are configuration problems, not equipment problems. You're not changing the equipment here. They all get fixed at the controller, not in the mechanical room. But here's the catch. Fixing a schedule without real data is just guessing. People tend to guess in the direction of caution, keeping schedules longer than needed to avoid complaints. But the data you need isn't complicated. You just need a couple of key pieces of information. If your building doesn't have a badge reader, you can look at things like the carbon dioxide level rising to estimate occupancy patterns or motion sensors. And then you're also going to want some zone temperature data so that you can see whether the set point is actually being met during the occupied hours and whether the setback is being hit during unoccupied hours. With those 3 streams of data over a few weeks, the correct schedule for the building is going to become pretty obvious. Not inferred, obvious, based on real data. And again, this comes back to our recurring theme of ground truth. The gap between runtime and actual occupancy plus appropriate pre-start is exactly the number of hours you can remove from the schedule without impacting anybody's comfort, and that will save you money. The correction process is 5 steps. Step 1 is pull 2 to 4 weeks of runtime and occupancy data. For a simple schedule, 2 weeks of data may be enough. 4 is probably better if the building has a lot of variability across days of the week. Step 2, identify the gap. Look at the runtime curve and the occupancy curve, and the area between them is the waste. Step 3 is to draft the corrected schedule, and this includes the occupancy hours, the correct pre-start window, holidays for the coming year, and any special use exceptions. And then step 4 is to apply those changes at your controller. For a standalone thermostat, that's typically going to be your programming interface, which may take you 10 or 15 minutes. Step 5, and this is the one that people skip, is to verify this. Watch the next 4 weeks. Temperatures should still hit the set point during occupied hours. Nobody should be complaining about comfort, but your runtime should be down, proportional to the hours that you've removed. If all of those are true, the correction's good and will keep paying you back every year until the schedule changes again. And if something's off, you'll have the data to see exactly what and adjust. Research from PNNL and field measurements consistently show schedule corrections alone saving 8 to 15% of the HVAC runtime in buildings where the schedule is drifted. For a 20,000 square foot building with typical energy costs, that's roughly $2,800 to $5,400 a year. For a 50,000 square foot school, $7,000 to $14,000 a year. These numbers compound because the energy savings recur every year the corrected schedule is maintained, which is why ongoing data matters. Schedules drift, building patterns change, buildings themselves change. A correction made once and never re-verified is always going to degrade over time. The data layer will always catch that drift and make the next correction easy. And that's the core difference between a one-time energy audit and continuous monitoring. The audit gets you a single correction. The monitoring makes every future correction cheap and on target. Schedule optimization is not glamorous. It's not sexy. It's not a chiller replacement or shiny new equipment. Nobody writes a press release about schedule optimization. And yet, dollar for dollar, it's probably one of the highest return interventions available in most small commercial buildings. 15 minutes at the controller when you're armed with the right data, recurring savings every year. The only thing standing in the way is getting that data, and the data layer is the relatively cheap part. The full article with citations from DOE and PNNL are on FractionalBAS.com if you want to learn more. The next video in this series walks through how to read a building's environmental report start to finish. Thanks for watching.